Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about the set interface in Java. By the end of this video, you will understand what a set is, what are the characteristics and different implementations, and when to use set interface and which type of set. So let's get started. So what is set? A set is an interface in the Java collection framework. Its main purpose is to store unique elements. Okay, unlike a list, it does not follow duplicate values. So as we have seen in the list, we can store duplicate values. Okay, so set is a part of collection framework. So we have seen in the hierarchy, right? So iterable is the parent interface, then collection is the child interface of iterable, then collection interface has three child interface. Those are list, set, and queue. So we are learning as part of this video set interface. These are what? Interface. Set interface and collection is also interface. Iterable is also interface. These are all our interfaces. But the implementation class of the set has three implementation class, that is HashSet, LinkedHashSet, and TreeSet. Okay, so these are what? Implementation classes. The classes which are implementing set interface. So this is the hierarchy we have learned. So we are learning set. So set is a part of collection framework. This is what? Collection framework. Okay. And the properties of set is it stores unique elements. Unique element in the sense we cannot store duplicate element in the set. So no duplicate values are allowed to store in the set. It represents a mathematical set. So the important point to note here is only unique elements, or you can say no duplicate values, are allowed in the set. Okay. So what are the characteristics of set? So the set interface have several important characteristics. Okay, it does not allow duplicate elements, so no duplicate elements, and it is not index based. Okay, as we have the list interface is index based, it supports index based operation, but whereas set does not support index based operations. Okay, and it can store one null value. Okay, only one null value we can store as part of the set, and faster searching than list in many cases. Okay, it is faster in searching, and it extends collection interface. Just now we have seen in the hierarchy iterable, then collection, then we have three interfaces: list, set, and queue. So set extends the collection interface. That's what it is telling. So if you know the hierarchy, keep hierarchy in mind and try to understand the properties like set does not allow to hold duplicate elements, and it does not support index based operations. It can store only one null values. Okay, so these are the properties, characteristics of set. So let's see the hierarchy of set. So this is the set hierarchy. So first one is root, that is iterable. This is interface, not class. Okay, iterable is the topmost interface, parent interface. Then collection is the child interface of iterable. So collection is the interface. It provides general collection features like add all, remove all, query. So these are the like common methods which is present in the collection interface. And set is the child interface of the collection interface. So, and set does not allow duplicate elements. Just now we have seen. Set does not allow duplicate elements. That is, only unique items will be stored in the set. So these are interface. Iterable is interface, collection is interface, set is interface. But the implementation class of set is three: HashSet, LinkedHashSet, and TreeSet. So we will see. So HashSet, okay, HashSet means no order guaranteed. That means order is not guaranteed here. HashSet, no order, no sorting. Order means insertion order, in which order the elements are getting stored in the hash set. That order will not be remembered by the hash set. And also we cannot sort inside hash set, that is sorting will not be there automatically. Okay, so no insertion order, no ordering, and no sorting. Okay, no ordering, no sorting in hash set. And if we talk about linked hash set, okay, it remembers insertion order, maintains insertion order. So here ordering will be there, but no sorting. Sorting means ascending to descending, descending to ascending. Automatically the class will do. So that thing is not available in linked hash set and hash set. So for hash set, no ordering, no sorting. For linked hash set, ordering, but no sorting. And in TreeSet, it maintains sorted natural order. So it provides sorting, but no ordering. Okay. So only 2 points we need to take care, like ordering and sorting. So first we need to understand what is ordering. Ordering means the insertion order in which the elements are getting inserted into this implementation object, class object, in which order. So those order is remembered in, so we will call it as ordering. Okay. And the second point is sorting. Sorting means it can be ascending or descending. So while creating an object, we can tell that implementation class, okay, sort it in ascending order or descending order. So ordering will be provided with the implementation class. So we call it as sorting. So those two features we need to compare for each of this class. Okay. So for HashSet, no ordering, no sorting. Both are not available in the HashSet. And for linked HashSet, it maintains insertion order. That's why ordering is allowed, but no sorting. And for TreeSet, no ordering, but sorting. TreeSet means always remember whether it is TreeSet. Okay. So sorting will be there. So we need to understand these 2 points. And apart from these 2 points, HashSet using hashing algorithm. Okay, we will see these implementation classes separately here. So we will understand. And we have learned time complexity O of 1. Okay, time complexity means how much time it will take if the size of this object grows. So that is measured by time complexity. So for HashSet, it is taking O of 1. For linked HashSet, time complexity is O of 1. Whereas TreeSet, it is O of log n. Okay. So time complexity can be asked as an interview, and mostly these 2 points are important as part of the set implementation class. Okay. So set extends the collection interface, and 3 commonly used implementations are HashSet, linked HashSet, and TreeSet. And each has different ordering and sorting behavior. We have discussed both. So let's first try to understand the first implementation class, that is HashSet. Okay, HashSet. So for HashSet, no duplicates allowed. So no duplicates means we cannot insert the two similar elements or two same elements inside HashSet. Since HashSet is the implementation class of set interface, and set interface says no duplicate allowed, that means for all three implementation classes, this property no duplicate will be applicable. Okay. whether it is HashSet, LinkedHashSet, or TreeSet. For all these three implementation classes, no duplicate. Why? Because these all three implementation classes are implementing set interface. So set is having this property. That means these three implementation class will be having that property. So for HashSet, first point is no duplicates are allowed. And for HashSet, we have seen no ordering and no sorting. No ordering, no sorting. That means insertion order will not be maintained. Okay, insertion order will not be maintained. That is no insertion order. The order in which elements are getting inserted will not be remembered by the HashSet. Okay, and no sorting. It will not provide any sorting. If you want to do custom, means by your own method, you can do it. Faster in performance. It provides hashing hashing algorithm. That's why it is faster in performance and it uses hash table. So HashSet is the most commonly used implementation. Okay, it does not maintain insertion order and neither it provides sorting, but it provides very fast insertion or deletion and searching. Okay, so now we will see LinkedHashSet. So this is another implementation class of the set interface. So LinkedHashSet maintains the insertion order. That's why ordering is there. Ordering is there, but no sorting. Okay. So these 2 points we need to keep for all these three implementation classes. So for LinkedHashSet, ordering is there, but no sorting. So no duplicates will be applicable for all three implementation classes, as these all three implementation classes are inheriting from implementing set interface. It maintains the insertion order. That's why ordering is applicable for LinkedHashSet. So the order you are inserting, it will remember the order. So let's say if you are inserting 10, 20, and 30, and if you are trying to retrieve through LinkedHashSet the elements, you will get in the same order, that is 10, 20, and 30. It will remember the order of insertion. And it is slightly slower than HashSet. Okay, so LinkedHashSet maintains the insertion order of elements while still preventing duplicates. It's useful when you need predictable iteration order. Okay, so let's see the third implementation class, that is TreeSet. And for TreeSet, we know there are two things: no ordering and it provides sorting. So it provides sorting but no ordering. These 2 points for this implementation class. So no duplicates, since it is implementing set interface and set interface has property, duplicates are not allowed. So TreeSet also no duplicates. And it provides sorting. That means while object creation only, we can tell that this implementation class whether it should be sorted in ascending or descending. So it provides sorting while object creation. Or okay, so it provides sorted order. And different types of trees are there, like red black tree, and the it is slower than HashSet. Okay, so tree is somewhat different than the HashSet and LinkedHashSet. So the TreeSet stores elements in sorted order. Okay, by default it sorts element in ascending order. By default means if you're not saying anything, you're not providing explicitly, then it will sort in the ascending order. And since it uses a tree data structure, operations are generally slower than HashSet. Okay. So let's go to IntelliJ and see some example to have better clarity. Okay. So what we are learning the set interface and their implementation classes. So let's create an object of, let's say, a set of string. Since we know the concept of generics, we will use generics. So I want to create a set of specific data type, that is string. And according set of string, and we'll use new HashSet. Okay, we need to import, and it belongs to java.util package. Okay, so if you observe in the left side, I have written set. So set is not the implementation class, right? Set is the interface. Interface can reference to object, and we all know object will be always of implementation class. We cannot create an object of interface, right? In the interface, we have seen the definition. Interface cannot be instantiated. So, but interface can refer the object. Okay, so that's why here interface and here object name. Here we can keep the object, this implementation class as well, but we are keeping interface name. So whenever we are using new, it should be always a class, not interface. So HashSet is the implementation class of the set interface. I hope this line is clear. Okay, so we have created one object of the HashSet, and we know the property of HashSet, no duplicates are allowed, and it follows hashing algorithm. Okay, and that's why it is faster in performance. And the two major points, it does not provide ordering and sorting both. Okay, so let's add some values like set.add, and we need to keep in mind we are using generics here, so we need to add same data type values, so in string only, so like Java, and let's say I will add Java programming, and I will add one more, add, okay, learning. So these three values I added, and it is of string type. If I try to give another type other than string data type, it will throw compilation error. Okay, so this is the advantage of using generics. During compile time only we will come to know if we are doing anything wrong. Okay, now I will print set. So you might be thinking, okay, for printing set we need to write one loop, and we have to iterate through each of these values like that. But that thing is already provided by the Java. So if you are directly using print set, so this implementation class has the toString method, and in that toString method, it has already implemented this thing for printing whatever element it has. So we can directly print this statement, and internally in this line it will call toString method, and it will print whatever elements it has. So let's verify it. See, Java programming learning, all three values got inserted. Now let's try to give some duplicates. So instead of learning, I am giving here Java now. So now I am trying to add duplicate. So Java programming and then again Java. Okay. So in case of set, instead of set, if it would have been list, then in case of list, it will insert all three elements, Java programming, Java. But whereas the properties characteristic of set says no duplicates are allowed, that means the implementation class, all three implementation class, same rule, no duplicates are allowed. So we cannot add Java, only Java programming will be there. Okay, let's verify it. So in the output, you can see only Java and programming are there. Okay, so here we are adding Java twice. Since set does not allow duplicates, only one copy will be stored. Okay, I hope it is clear. So this is the implementation, how we implement the implementation class in the, and how to add elements and how to verify that duplicate elements are not allowed. Okay, now, so here is a quick comparison between the implementation classes, that is HashSet, okay, HashSet, LinkedHashSet, and TreeSet. So just keep in mind the 2 pointers I told you, ordering and sorting. Ordering means the insertion order. The elements, the order in which elements are getting inserted is insertion order. So for HashSet, no insertion order, that is no ordering, no sorting. And for LinkedHashSet, ordering is there but no sorting. And for TreeSet, no ordering but sorting is there. So these 2 pointers we need to keep in mind for all these 3 implementation classes. And apart from these 2 points, one point is clear: no duplicates are allowed, since all these 3 implementation class implements the set interface, and set interface has the property no duplicates are allowed. Okay, so the first point is duplicates. So no for all, since they are all are implementing set interface. So no duplicates are allowed in all the 3 implementation class, that is HashSet, LinkedHashSet and TreeSet. And ordering, that is insertion order, is only provided for LinkedHashSet. Okay, so here no ordering and no sorting. And for this one, LinkedHashSet, ordering is there, that is insertion but no sorting. And for TreeSet, no ordering, it will not remember the insertion order, but sorting is there, that's why it is written sorted. Okay, and performance wise, if you talk about performance, HashSet is faster in performance. Why? Because it uses hashing algorithm. Okay, and LinkedHashSet is medium and the TreeSet is slower. Why slower? Because it works in a tree based data structure, so that's why it is slower. Okay, so HashSet is best for speed. If you see, HashSet is best for fast operations. Okay, and LinkedHashSet is best for remembering insertion order. It preserves insertion order. And if you want to sort, okay, your requirement is for sorting, then you should go for TreeSet. So based on our requirement, we should choose which implementation class we should go for. Okay, so if we are knowing these properties for all the 3 implementation classes, then we can easily take the decisions based on our requirement which implementation class we should use for our requirement. Okay, so this hierarchy we have seen as part of the collection. Okay, so iterable is the parent interface, then collection interface is the child interface of iterable. Okay, so collection we have seen a common method it provides. Okay, so these are the common methods which every interface can use. We can use in list also, and we can use in set also. These are the common methods: add all, contains, remove all, retain all, size, is empty. So these are common methods. Okay, we can use in list as well as set. So for set we have seen not an ordered collection. It does not support index based operation. It does not allow duplicates. Only one null element is allowed in the set. And what are the implementation classes of the set? HashSet, LinkedHashSet and TreeSet. Okay, so we are covering as part of this video as the set interface. Okay, so when to use set? So use a set whenever uniqueness is important. That's uniqueness means you don't want keep duplicates. Okay, so if you don't want duplicates, you want to store unique IDs, unique values, unique usernames. It can be unique email addresses. Okay, so in these cases you should go for set. Okay, and tags and categories. So based on your use, what is the requirement? We should select appropriate collection. Okay, so if we are knowing these properties, what list is having, what set is having, we can easily take decision and use it. Okay, So let's quickly summarize what we have learned so far. So set stores unique elements. Set stores unique elements. It does not allow duplicate values. And HashSet is known for faster in performance. LinkedHashSet is known for maintaining insertion order. The order in which the elements are getting stored is remembered by LinkedHashSet, and if we are retrieving the elements, we'll get the output in the same order in which they are inserted. Okay, and TreeSet is known for sorting. Okay, so based on our requirement, if you want sorted, we'll go for TreeSet. If you want to remember the insertion order, we will go for the LinkedHashSet. And if you want faster in performance, since it uses hashing algorithm, we'll go for HashSet. So based on our requirement, we will choose which implementation class to use. So that's all for this video. I hope this tutorial helped you understand the set interface in Java. Thanks for watching, and I will see you in the next video.